Hello everyone, hope you all are doing well. In this video, we'll discuss the second problem of Leetcode Weekly Contest 316. It's a medium level problem. The problem name is number of subarrays with GCD equals to k. So the problem statement says that given an integer array nums and an integer k, return the number of subarrays of nums where the greatest common divisor of the subarrays elements is k. Now a subarray is a contiguous non-empty sequence of elements within an array, and the GCD of an array is the largest integer that evenly divides all the array elements, right? These are certain examples. Let me just fetch the code as well, and then we'll see what yeah, let me just give you some examples. So the problem statement says that you are given an array nums. Let me write the array. So it's 9 3 1 2 6 and 3, right? And you are given an integer k. So let's, in this case it's 3. What we need to do, we need to find the number of subarrays of this array which has GCD equals to 3, given number, right? Now what is the GCD? GCD is basically, suppose I have certain numbers a, b, c, d, something like this. So GCD is the largest integer which divides all these integers. If I talk about GCD of these integers, so GCD of these integers will be a number dividing all these integers. Like for example, if I consider 2, 4, 6, 10. So in this case, what happens? What is the number that is dividing all of them? The largest integer. Obviously 1 is an integer that divides all the number, but 2 is also an integer. So just see, 2 divides this and this. So 2 will be the GCD in this case, right? So just thought of giving you an example of what is GCD. So yeah, this is GCD. Now we need to find the number of subarrays. So the actually there could be multiple methods to solve this problem. What I did was I applied a brute force here. So it says that the length of the number, that is n, is basically 1000. So that means what will be the time complexity if I calculate all the subarrays? Obviously that will be big O of n square, right? Because I run two loop. I goes from 0 to n, and then inside it my j goes from I to n, right? So what I do, I basically compute all the subarrays just because of the constraints, and while calculating those subarrays also, what I do, I calculate the GCD. Now GCD can be calculated using Euclidean algorithm. That is pretty simple stuff, right? Pretty common. If I just write a code, I won't waste too much time by writing the code, but it is simple. Like you pass two values here, right? This is a method which uses repetitive division, right? So what you do, if my b equals 0, right? So all you need to do is return 0. Return a. We try to make this number as 0. Why? We do something like this, else return. So how do you change these numbers? You write here b, in place of a you pass this, and then you take a mod, right? You do something like this. So actually this number has a possibility of becoming 0. It's a detailed explanation. We can prove it mathematically as well, but probably that is not the agenda of this video. So this is how you calculate the GCD. And hence what I do, I calculate all the subarrays, I call this function, and I see if my GCD equals to k for that particular subarray, I just increment my answer, and finally I return the answer, right? Now in this case, what will happen? The example that we have taken, so the array is 9 3 1, just a second, it's 9 3 1 2 6 3, right? These are the elements. So just see, if I just take this element, so, and k equals to 3, what is the GCD? Obviously the element, the GCD of a single element is that element itself, so it's 9. So it's not of any use for us. Let's take these two elements, 9 and 3. What will the GCD? GCD will be 3. So yes, I increment my answer becomes 1. I take these 3. Now you just see you've got a number which is less than GCD itself. So you won't be getting, irrespective of whatever number you add now in the array, you won't be getting a GCD which will be equal to k, or 3 in this case, right? So but again, if you take these, any of the subarrays now starting from here, you won't be getting k equals to 3, right? Because you've got 1 here. Now I start from here. So again, the first one that I got was 9 3. The second one that I got was only 3. Now again 1 comes here as soon as I include this element. So again, that's of no use. I start from 1 now. No, it's of no use. I start from 2. So 2, obviously GCD of 2 is not equals to k. I go here. Now GCD of these 2 is 2. That is again not equal to k. I take this, right? Now here you just see, is GCD equals to k? No, that is GCD in this case is 1. So you do not do anything. Now you start from here, right? You start from here, and then you see that, okay, is there a possibility 6 does not have a GCD of 3? Now you take 6 and 3. Now the GCD of 6 and 3 is basically 3. So 6 and 3 is one of my answer, and then finally I start from 3 and I get it. So there are 4 subarrays, so my answer will be 4 and I return 4 in this case. The second example is you have an array of 4 and k equals to 7. So there is no way you can pick just 4 and get a GCD of 7. So you return 0. That means I have 0 subarrays which have that answer, right? Let me just show you the code. So my code starts from line number 11. I see what's the length of the array, I take answer variable, and then as I told you, I run an nested loop from I equals to the I runs from 0 to n. My current GCD equals to the current number, that is nums of I. Now the inside loop will run from I to n. So current GCD equals to GCD of current GCD comma nums of j. And if GCD equals k, increment my answer. Now some of you may have thoughts that why am I starting j, why am I traversing from I, like why is j equals to I? This is just because I wanted to avoid an if condition. Otherwise I could have started from I plus 1 as well, but in that case for single elements I would have to add a check that if current GCD equals to k, then do this stuff and that. So just for simplicity I did that, and finally I return my answer. If I go to the GCD function on line number 3, so you just see what is there. The core logic is, if when a and b are passed, your GCD will be GCD of a and b equals to GCD of b comma a mod b. Again, there is a mathematical proof. If you want that, do tell me, I will create a separate video for that. That's not to be covered in this video. Finally you do this, and when your b becomes equals to 0, we return a, and finally we get our answer, right? So yeah, from this problem we learned that whatever is the problem statement, go to the constraint, see what the constraint is saying, and see whether an n square solution works in this case or not. That's the a main point to learn, right? Seeing the constraints helps you in deciding your time complexity, and based on that you can decide your algorithm, right? So yeah, I hope you learned something new from this video. Do support it by giving up a thumbs up. Do subscribe to the channel. In case you have any queries, do mention that into the comments. I'll revert on each one of them. Thank you. Take care. Bye bye.